Okay, well, welcome everyone. We're 1 minute away. All right, I think I have this where I want it. Everybody hear me? Okay, see a few nods. I did grade the, I guess I haven't graded them yet, but here's the results. So if you wanted to check your quiz to the answers, I will include this as probably a handout, not in the lecture notes, but I'll include this this copy so that you can look at it and compare your quiz to this. And then probably tomorrow I'll get to grading the quizzes. Okay, we're going to continue with hypothesis testing today. I promise that in a couple of weeks, these problems will take 5 minutes tops to do the whole thing. There are 5 steps that we require in the process of doing a hypothesis test, testing a claim about a single population proportion or a population mean. There are 5 steps. Some of them are faster than others in terms of completing, but to talk about the details and getting down into the weeds of writing hypotheses and gathering the evidence and so on, it takes some time at first. And I want a couple of the first videos to be in sufficient detail. And so that's why it's taking us so long to get through. But they will get faster, as you will see. We've talked about writing hypotheses. This is from section 10.1. We also looked at the step 2, which is identifying the level of significance. And we've done a little practice with that. Today, I'd like to look at 5. How do we interpret the decision that we make in step 4 for a hypothesis test? And where most of the work is going to be done is in step 3, where we gather the evidence. In all of our hypothesis tests, we will have, first of all, we'll have a calculator function to calculate the test statistic and the p-value. But in addition to that, there are many, many different ways to gather this evidence to make the decision. So, but every one of our calculator functions will first report the test statistic. And right now for us, just think of this as a z-score, something that you have been calculating all along. And they will give us the p-value. These are the 2 difficult calculations, and we will rely on the technology to do that. So one other thing from section 10.1 that we haven't yet discussed that maybe you've seen in the homework is this notion of a type 1 and a type 2 error. So that's where we're going to start today. Now here's a picture probably that I've drawn before. There's 2 different pictures here. There's one dealing with the proportion situation, and then there's another one dealing with the mean situation. If we know that if we have a large enough sample size, that the sampling distribution of all these samples, we have a population, we take a random sample and we calculate p hat. And that p hat might be this one. If we do it again and take another sample, that p hat might be over here. If we do it again, another p hat might be way over here. All of these sample proportions are possible when we take different samples. These sample proportions will vary from sample to sample. And we know that because the sampling distribution of all these is approximately normal, with the mean being the population proportion and the standard deviation being this formula, we know that since this curve is normal, we can say some things about the percentage of outcomes that fall in a certain range. So for example, since this is normal, we know about 95% of all the sample proportions will fall within like 2 standard deviations of the mean. But there are some samples that fall outside that area, just because it's possible. And there are. But when we do a hypothesis test, we are going to reject all the samples that we find out here. It's a perfectly fine sample, but we're going to reject this, and instead of saying that this is the population proportion, we're going to say that it's a population proportion that somebody claimed to be true. And so what we're going to do to test that claim is we're going to reject the claim if we find any sample proportion that is a long way from the sample proportion. And this really could be the sample proportion that we got, and we would be rejecting the null hypothesis, and we could be making an error because the population proportion really could be this, and we would get this sample just by random sampling variation. So there are times in statistics, because of the way that these sample proportions, and if you go over here, the same thing applies to the sample means, we will be rejecting the null hypothesis that the claim is this, when in fact the claim really is this. And so we will make regularly, we will make errors. It's just part of the process. And we have to recognize that. And so when we do one study and we get one sample proportion, we have to be very humble in how we report the conclusion, the interpretation, the final step. We'll never use words like, oh, we found this, and we reject the null hypothesis. Therefore, it proves that this isn't the population proportion. We cannot say that because everything that we conclude is based on selecting a single sample. So we can make a couple of errors when we do this. And there's two different kinds of errors, and those are known as the type 1 and type 2 errors. So I thought we'd start out today and talk a little bit about that. Okay, so we'll start off with type 1 and type 2 errors. Again, as before, I'm going to, periodically pose some questions, and I'll ask you to post your answer in the chat. Also, if you have questions, I will, periodically look over in the chat and answer your question. If I don't get to your question soon enough, then just turn on your mic by pressing your space bar, talk, and then release the space bar. All right, so here's how this is from section 10.1. So here's how we're going to interpret type 1 and type 2 errors. So we're going to have a grid. A 2x2 grid. And the variable up here is the reality of H0. There are two things. There are two hypotheses, the null hypothesis and the alternative. Only one can be true at a time. They are competing hypotheses. So in this column, we'll assume the null hypothesis is true. And over here, we'll assume that the null hypothesis is false. By the way, this is what I'm covering. This is one of your handouts. And here's a description of the type 1 and type 2 errors. Now, I may not have given it to you today to print out in today's handouts, but it would have been one in an earlier, on an earlier day that we just didn't get to. So I'm kind of reconstructing this table right here with a little bit more detail. The variable over on this side is the conclusion. And when we do a hypothesis test, there's one of two things. Well, maybe I should say decision instead of there's one of two things that we can do. We can reject the null hypothesis, or we can not fail to reject the null hypothesis. Those are the only two decisions that we can make. And up here, these are only the only two things that can occur in a hypothesis test. The null hypothesis is true or it's false. So I'm going to create a little graphic here for the null hypothesis and the alternative in each case, just so you can get a sense of what we're doing in each case. For this column, the null hypothesis is true, and that makes the alternative hypothesis false. Whereas over in this column here, the null hypothesis is false, and therefore the alternative hypothesis is true. So the null is false, and the alternative is true. Now going across here, in this row, we are going to reject the null hypothesis. So let's just put a little X through the null hypothesis saying that we're going to reject it. Similarly, down in the bottom row here, we're not going to reject the null hypothesis. So the null hypothesis is plausibly true. We're not going to reject it in favor of the alternative. So our evidence in each case would be like this, which would lead us to reject or not. And we normally don't know if the null hypothesis is true, but we assume it to be true. And because of that earlier graphic I showed you, it's possible to make an error. Okay, so let's go through the 4 scenarios. Let's say that this happened up in this box. What happened here? Let's review. The null hypothesis was true. We took a sample and we compared the sample results to the claim, and that led us to reject the null hypothesis. We got a sample proportion or a sample mean that was way outside, way out to the right or way out to the left, and it certainly would have been an unusual sample had the null hypothesis been true. So our procedures are going to require that we reject the null hypothesis, and that means we are showing support for the alternative hypothesis. So we're showing support for a false statement. If this happens, then there is an error because we rejected a true statement. And we're saying, oh, there's evidence for this false statement. Well, it's false. There shouldn't be evidence in favor of it. An error that happens like this is called a type 1 error. It's the error that occurs when we reject the null hypothesis when in fact it's true. Over here, let's say that these two things happened, that the null hypothesis was false, which means the alternative was true. And when we took our sample and did our test, we rejected the null hypothesis. So what happened in summary? What we did is we rejected a false statement in favor of a true statement. This is the correct decision. No error was found here. This is what we want to happen all the time. Unfortunately, it doesn't always happen that way. And let's go down to this one. All right, so tell me in the chat box, error or correct decision? Error or correct decision? In this case, the null hypothesis was true, and we failed to reject a true statement in favor of a false statement. Okay, type your response in there. Was the correct decision made here? Or is this an error in this scenario? Okay, thank you. You guys are right. This was a correct decision as well. We would want to not reject a true statement. We don't want to reject a true statement in favor of a false one. We always want to make the correct decision, and that's what would happen here. All right, so this is no error as well. And finally over here, this is a scenario where the null hypothesis is false, but we failed to reject this false statement in favor of the true. We could not, with this test, find support for the true statement. So here is another case where we have an error. An error was made. We failed to reject the false statement. We failed to show support for the true statement. We don't want this to happen. We don't want to make the error. But when we do statistics, we make errors. We make errors about 5% of the time. So we're going to be humble in reporting our results. All right, this is known as a type 2 error. This is the error that occurs when we fail to reject a false statement in favor of a true statement. So in summary, if you can see this well, there's 4 things that can happen. We have them outlined in the grid, 1, 2, 3, 4 that I just showed you. The first 2 are correct decisions. The type 1 error is when we reject the null hypothesis when the null hypothesis is in fact true. And this decision would be incorrect, therefore it's an error. That's this one right here. The other error we can make is when we fail to reject the null hypothesis when the alternative is true. So we couldn't find support for the true hypothesis. That's another error, and that's the one down here. Okay, so you should have these, this summary on the section 10.1 notes. An application of this where it will appear would be in a trial. And so I think on this handout here, they refer to it a little bit right there, the null hypothesis. Think about a jury trial. There are 2 outcomes for the defendant. The defendant is either innocent or guilty of the crime. And on the other hand, the verdict comes back from the jury, and the jury can say not guilty or guilty. So there's two outcomes there as well. So here is kind of the grid, which is similar to the type 1, type 2 situation. Here, the null hypothesis is true and the alternative is false. In this case, the defendant is innocent. If the defendant is innocent, but the jury comes back with a guilty verdict, an error was made. An innocent defendant is sent to prison. This is injustice, right? We don't want this to happen. Over here, the defendant is guilty. The defendant actually did the crime, whatever it was. And the jury comes back with a guilty verdict. The jury did, in fact, make the correct decision there. They found a guilty defendant guilty, correct decision. Well, what else can happen? Well, the jury can come back with a not guilty verdict. Well, if the defendant is innocent, then we would like the jury to come back with a not guilty verdict. This is the correct decision. An innocent defendant is found not guilty. And this one over here is a similar error. This is like the equivalent of a type 2 error. The defendant is guilty. They did the crime, whatever it was, but the jury came back and said there's not enough evidence to return a guilty verdict, so they find him not guilty. So in this case, a guilty defendant is found not guilty and then is acquitted of the crime. So again, another error. So something similar to the type 1 and type 2 errors. I now want to switch and do a couple problems. So I'll do a couple problems that you will see, and then we'll I'll let you work on a couple. I can find it here. Oh well. All right, so the problems will look like this. The first thing in this section, they ask you to practice a little bit more writing the null and alternative hypotheses. So I'll just briefly do that. And then the new stuff would be, okay, if these are the hypotheses, then what would it mean to make a type 1 error? Interpret what that would be. And then finally, explain what it would mean to make a type 2 error. The only time a type 1 error can occur is when we reject the null hypothesis. Here's the type 1 error, and it only happens when we reject the null hypothesis. On the other hand, a type 2 error is one that can only occur when we fail to reject the null hypothesis. So keep that in mind as we go forward. All right, so for students who, by the way, I'm going to include these notes. So if you don't get everything, then they will appear in what I upload later on today. The proportion of students that earned a bachelor's degree within 6 years, the national average is about 40%, 39.9%. This is the national average. Students who first enroll in 2-year colleges, if you follow that cohort from the fall of 2007 out 6 years in advance, then only 40% of students that started from that fall 2007 cohort actually get a bachelor's degree within 6 years. That's what that means. That's the national average. Okay, the president of Joliet Junior College believes that the proportion of students who enroll in her institution have a higher completion rate, and that means higher than the national average. That means greater than 0.399. So maybe the president believes that it's 45% instead of the 40%. But that's the claim we're going to test here. Notice it has it's referring to a percentage of students, so we use a proportion for that. And the proportion is greater than 0.399, that's the claim. Here's the alternative. All right, now if part B, if a type 1 error is made, then that means the null hypothesis had to be rejected. And if the null hypothesis was rejected, and it was in fact an error made, a type 1 error, then what that means is that we rejected the null hypothesis when in fact it was true. So we start off with just the generic definition of what a type 1 error is. We reject the null hypothesis when it's in fact true, and then we write it up in terms of the context of the problem. So it might look something like this. We reject that the proportion of students who earned a bachelor's degree within 6 years is 39.9%. So I'm basically saying, here's the null hypothesis that we rejected in favor of the claim that the percentage is higher than 39.9%. So we rejected a true statement in favor of a false statement, when in fact, the proportion is not greater than 0.399, when in fact, the proportion very well could be 0.399. So reject the null hypothesis when it in fact is true. That's how you would write the interpretation of a type 1 error here. Okay, and part C says, explain what it would mean to make a type 2 error. Now, type 2 error is the one when we fail to reject the null hypothesis when it's false. So the null hypothesis is false. We should have rejected it in favor of the alternative that was true, but we didn't because of the sample that we selected. All right, so then you just write that up again in the context of the situation. So in this case, we failed to reject the null hypothesis when the alternative hypothesis is in fact true. So again, we made this error. So we failed to reject the null hypothesis when in fact the proportion is actually higher than 0.399. All right, now we're going to look at number 16. A similar problem. Historically, the time to order and deliver a pizza at Jimbo's Pizza was 48 minutes. So on average, just think about all the data that is collected here. Jimbo's staff delivers a pizza. Some take 45 minutes, some take 55 minutes, some take 48, 49, 49, 49, 50, 47. And they take all those delivery times and they average them all out. And they find that the average time was 48 minutes. Well, Jimbo, the owner, implements a new system for ordering and delivering pizzas that he believes, so here's his claim, will reduce the time. And the current time is 48 minutes. And if there's a reduction in time, that means the delivery time is, on average, less than 48 minutes. So when writing the hypotheses, this is a less than sign. The less than sign always goes in the alternative hypothesis, and that is the claim. And notice that the claim is in the alternative. Is this a one-tailed test, two-tailed test? If it's a one-tailed test, is it left-tailed or right-tailed? Go ahead and write your answer in the chat box. Left-tailed, right-tailed, left, right, two. Okay, very good, left-tailed test. All right, so again, same kind of problem. We're going to interpret what is meant in part B, what it means to make a type 1 error. That means we reject the null hypothesis when it's true. And so in this context, we're rejecting that the mean is 48 in favor of the mean is less than 48 minutes. And this is an error, so that must mean that the mean is in fact 48 minutes. It didn't shrink as a result of the new system for ordering and delivering. So here's how you can say that. We reject the null hypothesis in favor of the alternative hypothesis when the mean time is or we reject the null in favor of the alternative that says that the mean is less than 48 minutes, when in fact the mean is not less than 48 minutes, when in fact the average time still is 48 minutes. Reject the null hypothesis when it is in fact true. And then what would a type 2 error mean in this case? That means we fail to reject the null hypothesis when in fact the mean delivery time is in fact less than 48 minutes. Okay, so type 1, type 2 errors. So I'd like to now give you about 5 minutes to work on two more problems. So there's another worksheet in your packet there that looks a lot like this, but instead of problems 15 and 16, they're going to be problems 17 and 18. So, and let me see if I can. Maybe I can find a copy of those in case you don't have them handy. Well, of course I don't. All right. So anyways, if you don't have this handy, here's problem 17. It's the same things. Go ahead and write the hypotheses. Write the hypotheses, explain what a type 1 error would mean, and explain what a type 2 error would mean. Okay, let's take a look at number 17. And let me slide this up a little bit so you can see problem 18 if you don't have it in front of you, and you can work on that. So, all right, so the claim was that the mean believes that the existing home prices in her neighborhood are lower than the 245,700. So there's the claim. The alternative would be, or the null hypothesis would be this. Type 1 error would mean we reject the null hypothesis when it's true. So we reject that the mean is $245,700 when in fact the mean is 245,700 and it is not less than 245,700. So that's what you'd want to say there. Use your own words, use it in context. You're going to use these numbers, use the dollar amount. And then the type 2 error would be where we fail to reject a false statement. Something's false, we fail to reject it, and therefore we're left with showing evidence for a false statement, which we don't want to do with a lot of frequency. So we fail to reject it, and so we would say we fail to reject that the mean is $245,700 when in fact the mean is less than 245,700. And the last one, consumer advocate feels that a certain peanut butter manufacturer is shorting customers. So if you think about the data here, they measure the amount of peanut butter in a jar, and a machine fills these things. So it might be 31 ounces in this jar, 33 ounces in that jar. Of course, it's not going to be 35 ounces because that would probably overfill the jar and they'd know that there's a problem. So you're going to get filled amounts close to 32, like 32.1, 32.2, 31.9, and so on. So if the manufacturer is shorting customers, then that means that on average, the amount of peanut butter in the jar is less than what they advertise, 32 ounces. So there's the claim. It's got the less than sign, so therefore it's in the alternative hypothesis, and then there's the null. We reject the null hypothesis and make an error. We're rejecting that the manufacturer isn't cheating the customers when in fact they're not cheating the customers. And you could say it this way with amounts of peanut butter. We reject the null hypothesis in favor of the alternative. That is that the mean is less than 32 ounces when in fact the manufacturer is not shorting the customer and the mean is 32 ounces. And then here's the similar interpretation of a type 2 error in this case. We fail to reject the false statement in favor of the true one. So in this case, the manufacturer really would be shorting customers, but we claim the evidence says that they're not. We made an error.